In this collab, we'll see how to create a convolutional neural network. Let's start by checking that GPU execution is enabled to speed things up. This collab will also do image classification on the Fashion MNIST dataset, so it's very similar to the previous collab. We will therefore fast forward to the things that are different in this collab. We've now come to the part where we create our convolutional model. The first layer is a convolutional layer with a 3x3 kernel and padding to keep the original image size. The 32 here specifies that 32 convoluted outputs will be created, so we're going from a single input image to 32 convoluted ones after this step. The next layer is a max pooling layer with a 2x2 size and a stride of 2. This will reduce the size of all the 32 convoluted images. Then we perform a similar round of convolution and max pool. In this case though, we will create 64 convoluted outputs, and as before, we max pool the result. So far in the course we've described what a convolutional layer does, but we haven't yet covered how you chain multiple of these convolutional outputs together. For more detail on this, see the text below the collab for references. We will also get back to this in lesson 4 when we start to use color images. At this point, it's enough if you have a high-level understanding of the type of operation a convolutional layer performs. The flatten layer here takes all of the previous data and flattens it into a one-dimensional array. Then we have a dense layer with 128 neurons and the ReLU activation. And finally, a dense layer with our 10 class scores as a probability distribution, since we're using the softmax activation function. We compile our model exactly like before, and then we train our model using the same iteration parameters, but in this case we use 10 epochs, so we train for a total of 600,000 examples. As you can see, we get an amazing 98% accuracy on the training dataset, so it appears that convolutional networks are amazing. Remember that our previous network only achieved about 88% accuracy. Let's try this on the test dataset. Here we can see a significant drop in accuracy to 92%. The reason is that we used so many epochs during training that our convolutional network started overfitting or memorizing our training data. See the text below this video for a short discussion on this. Also, in the next lesson, we'll introduce techniques to avoid this. In any case, 92% is significantly better than 88% that we got with our dense layer, so convolutional neural networks are superior for this task. The rest of the collab is the same as before, so let's fast forward to the exercises at the end. Okay, so here are some exercises specifically for the convolutional neural network. Good luck!